The world is entering an era where copying doesn't happen slowly anymore. It happens instantly. Yeah, China can copy pretty much everything. Whatever technology the world comes up with, China will have it right away, even if it's a lower quality version. When a breakthrough product shows up in Silicon Valley, it doesn't stay unique for long. In a manufacturing ecosystem as dense and fast-moving as China's, lookalike products can pop up almost immediately. Elon Musk understands this better than most people. He said many times that Tesla operates in a world where successful designs get copied fast. That's why in recent years, Tesla has kept its design language and technical details under wraps until launch day. It's not a marketing gimmick, it's a defensive strategy. Once a design goes public, the global copying machine kicks into gear. The Model X was copied before, and now it's happening to the Tesla Semi. Yeah, this is the Windrose Truck, a Chinese Class 8 truck, and it looks about 80% like the Tesla Semi. We honestly think a lot of people would get them mixed up if they didn't look closely. So the big question is, can the copy beat the original? Let's break it down and compare them in detail right now. Okay, copying isn't always a bad thing. If we don't learn from better ideas, global technology wouldn't be able to move forward. But when you're a business, copying a competitor's product design so closely that it looks 70% or even 80% the same is definitely not something you should be doing. If the Windrose Truck reminded you of the Tesla Semi the moment you saw it, and that thought popped into your head instantly, drop a comment below. The first time we saw images of the Windrose electric truck, we immediately thought of the Tesla Semi. We even mistook it for a new version of the Tesla truck. Just look at it. The overall shape, the forward-centered cab layout, and the smooth, aerodynamic form are extremely similar to what Tesla introduced with the Semi years ago. And this isn't a coincidence. The Tesla Semi was inspired by Japan's bullet trains, which gives it an ultra-low drag coefficient of just 0.36. Thanks to that incredible efficiency, the Tesla Semi is the only electric truck capable of going 500 miles while consuming just 1.7 kilowatt-hours per mile. Yeah, so far, no other Class 8 tractor in the world has been able to hit those numbers. So the question is this level of efficiency exactly what made the semi-truck so easy to copy? When you design a Class 8 electric truck for maximum efficiency, the laws of physics start limiting how creative you can be. A rounded nose reduces drag. A tall roofline helps manage airflow over the trailer, and a narrow front improves range at highway speeds. The Tesla Semi set that template early on, and Windrose clearly seems to be following the exact same aerodynamic playbook. Windrose uses a nose shape very similar to the Tesla Semi, along with a wide, panoramic windshield to improve visibility and airflow management. Because of that, it reportedly achieves an even lower drag coefficient than the Tesla Semi, just 0.27. When you look at the light bars on both trucks, it's hard not to see them as twins, even though they're made by completely different manufacturers. Okay, if you think this is just a coincidence or light inspiration, then take a look inside the driver's cabin. This is where the evidence becomes impossible to ignore. A lot of people don't like the Tesla Semi's center seat driving position, and it's been controversial ever since launch. But at the same time, that design gives it a unique identity you won't find on any other Class 8 truck, where the driver's seat is almost always on the left. Now look at the Windrose Truck's cabin. It's a near-perfect copy, from the center driving position to the two touchscreens on either side. To be fair, Windrose does deserve some credit. It includes a sleeper cab, even with a small kitchenette, which makes it much more suitable for long-haul transport. The Tesla Semi still doesn't offer a standard sleeper cab, as Tesla is currently more focused on shorter-range freight operations. From what we understand, the Tesla Semi's cockpit was designed in parallel with its charging and parking concepts. That includes how drivers get in and out of the cab, how mirrors and camera systems compensate for the unusual seating position, and how service access works in a fleet operating environment. Windrose may be able to copy the visual layout, but without the same level of ecosystem integration. The experience could end up being just surface-level imitation rather than a deeply engineered solution. Okay, putting design aside for a moment, let's talk about performance specs, because we believe this is what really determines which truck is more effective. The reality is, both of these trucks come in two main variants, built to meet different transport needs in the long-haul Class 8 electric truck segment. The Tesla Semi is offered in standard range and long-range versions, while the Windrose R700 also comes in two comparable configurations. When it comes to range, the single most critical factor for long-haul trucking, the Tesla Semi Long Range delivers 500 miles while hauling a full Class 8 gross combined weight rating of 82,000 pounds under U.S. standards. So far, that's still a benchmark very few competitors have been able to touch. Meanwhile, the standard range version is rated at 325 miles at the same load. Both variants maintain the same energy consumption of about 1.7 kilowatt-hours per mile, which essentially reveals the battery size is roughly 550 kilowatt-hours for the standard range and about 850 to 900 kilowatt-hours for the long range. According to the official website, the Windrose R700 long range uses a 705 kilowatt-hour LFP battery and is rated for 420 miles at an 82,000-pound load. On the other hand, the standard version uses an NCM ternary lithium battery with a capacity of 486 kilowatt-hours, targeting around 295 miles, making it more suitable for regional hauling. Clearly, Windrose is impressive, but the Tesla long range still wears the crown when it comes to range. With 500 miles at maximum load, the Tesla long range significantly outpaces the Windrose long range's 420 miles. You might not realize this, but an 80-mile difference may not sound like much for passenger cars yet in long-haul trucking. It's a strategic gap. Those extra 80 miles can be the difference between needing a mid-route charging stop or not. They also provide a buffer against headwinds, steep grades, or bad weather. On the flip side, Windrose chose a smaller battery for its long-range version 705 kilowatt-hours versus Tesla's estimated nearly 900 kilowatt-hours. This helps reduce battery weight, potentially improving payload capacity and lowering upfront costs. The trade-off, of course, is reduced range. It's a classic balance between cost and performance. What's particularly interesting is that Windrose uses two different battery chemistries across its lineup: LFP for the long range and NCM for the standard version. That's notable because NCM typically offers higher energy density than LFP. Using a large capacity LFP pack for the long range likely helps optimize cost and cycle life, while using NCM in the standard version keeps weight down at smaller capacities. It's a flexible approach, but it also makes the product ecosystem more complex. One extremely important factor that often gets overlooked when comparing Class 8 electric trucks is curb weight. This isn't just a technical spec buried on a website, it directly affects real-world payload capacity and profit per trip. In long-haul logistics, every single pound matters. In the US, the standard maximum gross combined weight for Class 8 trucks is 82,000 pounds. That means the heavier the truck itself is, the less weight is left for cargo. And with electric trucks, where battery packs alone can weigh several thousand pounds, the weight equation becomes more critical than ever. According to Tesla's website data, the Tesla semi-standard range has a curb weight of under 20,000 pounds. The long-range version comes in at around 23,000 pounds. For a Class 8 electric truck, those are extremely impressive numbers. To put that into context, many other electric trucks in this segment typically weigh well over 25,000 to 27,000 pounds because of massive battery packs and complex cooling systems. If the Tesla semi-standard range really is under 20,000 pounds, that creates a clear payload advantage. With the Class 8 US gross combined weight limit of 82,000 pounds, a standard range semi could allocate more than 62,000 pounds to the trailer and cargo. The long-range version, at roughly 23,000 pounds, still leaves around 59,000 pounds for payload. The roughly 3,000-pound difference between the two variants mainly comes from the larger battery pack, but Tesla still manages to keep the overall structure relatively lightweight compared to the industry average. Now let's look at the Windrose R700. According to its official website, the long-range version weighs 26,235 pounds, while the standard version comes in at 21,605 pounds. These numbers show that the Windrose standard is getting close to the Tesla standard, but the Windrose long range is more than 3,000 pounds heavier than the Tesla long range. In real-world operations, 3,000 pounds is not a small number. In freight transport, that can mean an extra pallet of cargo or much more flexibility when hauling heavy goods like steel, construction materials, or frozen food. For a fleet running thousands of trips per year, that additional payload capacity can translate directly into meaningful revenue. That said, we need to look deeper instead of focusing only on the weight difference. The Windrose long range uses a 705 kilowatt-hour LFP battery pack, while the Tesla long range is estimated at around 850 to 900 kilowatt-hours. What's interesting is that even with a larger battery, Tesla's reported curb weight is still lower. That likely reflects differences in chassis design, structural optimization, and how the drivetrain is integrated. Tesla has long followed a vertically integrated philosophy, from battery cell design to modules, packs, and thermal management software. If the battery structure is better optimized for energy density and the chassis is designed as a more unified system, Tesla can achieve better weight efficiency per stored kWh. On the other hand, Windrose may be accepting a heavier structure in exchange for lower costs or higher mechanical durability. A heavier truck doesn't automatically mean it's less effective, especially if it's built to handle tough operating conditions and high structural loads. But within the fixed 82,000-pound gross combined weight limit, every extra pound of curb weight directly reduces the amount of cargo you can carry. This leads to an important conclusion. Efficiency isn't just about range or kilowatt-hours per mile. It's also about payload efficiency per trip. If two trucks can both run 400 to 500 miles, but one can haul 2 to 3% more cargo each time, that difference can turn into a clear economic advantage over the long run. In short, when it comes strictly to curb weight, the Tesla Semi holds a noticeable edge, especially in the long-range variant. The Windrose Standard is fairly competitive, but the Windrose Long Range is significantly heavier, which could impact real-world payload capacity and operating economics. Fast charging speed directly determines driver downtime and overall fleet efficiency, because in long-haul trucking, every minute stopped impacts asset utilization and revenue. The Tesla Semi Long Range supports the MCS standard with peak charging power of up to about 1.2 megawatts, allowing it to recover roughly 60% of its range in just 30 minutes. With a 500-mile range, that's equivalent to adding around 300 miles in half an hour, a huge advantage when combined with Tesla's dedicated megacharger network in the US, along with tightly integrated thermal management and fleet-optimized software. Meanwhile, the Windrose R700 uses a dual-inlet megawatt charging setup, supporting both CCS1 and MCS to increase infrastructure flexibility. The standard range version supports up to 818 kilowatts on MCS and 409 kilowatts on CCS1, charging from 20 to 80% in about 35 minutes. For the long-range version, the Windrose R700 supports up to 745 kilowatts on MCS and 372 kilowatts on CCS1, reaching 20 to 80% in roughly 38 minutes. In real-world terms, the Windrose Long Range can add about 250 miles in under 40 minutes, which is quite competitive for the segment. The added CCS1 compatibility also means it's not fully dependent on the still expanding MCS network. That said, if we compare pure peak power and miles added per minute under ideal conditions, the Tesla Semi still has the edge thanks to its 1.2 megawatt charging capability and larger total range, giving it a clear advantage in reducing turnaround time on interstate routes. Put simply, Windrose scores points for openness and charging infrastructure flexibility, while Tesla leads in peak charging speed and deep ecosystem integration. And in logistics, that difference can translate directly into long-term operational efficiency. Looking ahead to 2026, the competition between the Tesla Semi and the Windrose R700 in the U.S. long-haul Class 8 electric truck market won't just be about range or charging speed. It will increasingly center on something even more practical: purchase price and total cost of ownership. For fleet operators, especially large carriers running hundreds of tractors, the upfront price can ultimately determine how fast they transition to electrification. Based on current market information, the Windrose R700 is expected to start at around $250,000. This figure has been cited by industry outlets like Clean Trucking and Charged EVs as the target price for the USS market. Windrose has already opened reservations in the USS, with a $15,000 refundable deposit per truck through its official website. This move signals that the company is serious about expanding its U.S. presence, starting in California and delivering trucks along the I-10 corridor. From a corporate and supply chain perspective, Windrose was founded in 2022 and operates an assembly plant in Belgium for the European market. While key components, such as the chassis, e-axles, battery packs, and suspension systems are manufactured in China, this supply chain strategy helps the company keep production costs under control, allowing it to offer more aggressive pricing compared to many other Class 8 electric trucks on the market. On top of that, Windrose is offering 3 months of free charging on the Green Lane network for U.S. customers, which can significantly reduce early operating costs and help narrow the gap with traditional diesel trucks during the transition phase. On the other side of the comparison, the Tesla Semi comes in at a higher price point. The standard range version has been disclosed at around $260,000, while the long-range version is closer to $290,000, not including delivery fees, taxes, or other additional costs. This is a noticeable increase from Tesla's original 2017 estimates of $150,000 to $180,000, reflecting the impact of inflation, higher battery costs, and a longer-than-expected development cycle. That said, it's important to look at the bigger picture according to data from the California Air Resources Board. The average price of many Class 8 electric trucks on the market can reach around $435,000. In that context, Tesla's pricing is still relatively competitive compared to the broader industry landscape. If we look purely at upfront purchase price, the Windrose Long Range is about $40,000 cheaper than the Tesla Semi-Long Range, $250,000 versus $290,000. For fleets buying dozens or even hundreds of trucks, that gap can easily add up to millions of dollars in capital savings. On top of that, Windrose offers a practical sleeper cab and flexible dual MCS and CCS1 charging, which is appealing for operators who want access to multiple charging networks instead of being tied to a single ecosystem. That said, upfront price isn't the whole story. The Tesla Semi-Long Range delivers 500 miles of range, compared to 420 miles for the Windrose Long Range. Tesla is also lighter, which translates into higher usable payload within the 82,000-pound gross combined weight limit, with energy efficiency of around 1.7 kilowatt-hours per mile, peak charging up to 1.2 megawatts, and an integrated megacharger network. The Tesla Semi gains an advantage in turnaround time and energy cost per mile. When you calculate total cost of ownership over 5-7 years of operation, factors like lower energy consumption, shorter charging stops, higher payload capacity, and reduced maintenance can offset the higher upfront price. Beyond that, Tesla also brings a strong software platform and long-term autonomy potential, which could create additional value for large-scale fleet operators over time. The Windrose R700 has emerged as one of the closest and most direct competitors to the Tesla Semi in the Class 8 electric truck segment. Windrose's design is clearly heavily inspired by Tesla, a center-mounted driver's seat for improved visibility, a smooth, futuristic aerodynamic shape, and camera-based mirror systems replacing traditional side mirrors. All of it adds up to a look that feels uncannily Tesla-like. That said, if we take a more optimistic view, Windrose also brings some genuine improvements over Tesla. It's more driver-friendly for long-haul routes, thanks to a sleeper cab that offers real resting space and even a small kitchenette features that the Tesla Semi still doesn't offer as standard. The Windrose cabin is designed to deliver more practical comfort on multi-day trips, while still maintaining a modern, minimalist look with large displays and a clean, user-friendly interface. Yeah, in contrast, the Tesla Semi leans into a pure day cab philosophy, emphasizing extreme minimalism and future autonomy readiness. Windrose, meanwhile, aims for a balance between futuristic aesthetics and the everyday needs of professional long-haul drivers. So what do you think about these two trucks? Are you okay with this kind of design borrowing? Drop a comment below, and thanks for watching.